Alright, so welcome back again. My name is Jesse, and in this wonderful and exciting tutorial, we're trying to explore object-oriented programming in Python. So what is object-oriented programming? So there are several ways we can solve problems in code, right? And one of the ways is in the concept or the pattern of object-oriented programming. So what is an object? So simply put, an object is anything that has a state and an attribute, right? So it has a state and an attribute. So what do I mean? If I go back here and I say, give me examples of an object. So you can give a light bulb, you can give a bank account, a car, a human being, a student, anything, right? So why? Because it has a state and a behavior. So if you take a light bulb, the light bulb has a state. So the state describes the attribute, the data it is carrying, right? Then the behavior is what it does. So a light bulb has a state, it can be on, it can be off. It has an attribute, so the attribute is that it can be on, it can be off. It's having maybe this particular type of glass. All of these things are the attribute. Then you also have the behavior, right? So the behavior is what it does, the methods it can do. So you can switch on, you can switch off, you can check if it is on. Another object is a bank account. So a bank account is an object. It has a state and it has a behavior, right? So the behavior that you can make deposit into it, you can withdraw, you can check balance. Another one is a car. So a car has a state or an attribute. It has tires, it has an engine, it has glasses, it runs a particular mile. That ability for it to drive it, to change gas, to check odometer reading, all of that is the behavior. So an object is anything that has, is everything that has a state or attribute and a behavior, right? That is an object. So how do you create an object? So to create this particular light bulb, you need a way of creating it, right? So one of the ways of creating a light bulb is to go to the factory, and then when you go to the factory, they have a model, they have a blueprint, right? So that blueprint, that model is what they are going to use to create this light bulb. That blueprint, if you go to a car factory, they have a blueprint, they have a particular model they use to create this particular car. So that particular model or blueprint in object-oriented programming is termed as a car, as a class, right? So if I come back here, so a class is the blueprint we use to create an object, right? The blueprint to create an object is called a class. So in case I want to create any class, in case I want to create any object, I need to get a blueprint, and that blueprint is termed as a class. So behind every object, right, we have a blueprint for creating that particular object, which is called a class. So let me show you an example. So in case I want to create this particular car, this is the blueprint. So inside the blueprint, it's like a questionnaire, it's like a form. Within this particular blueprint, I'll specify the ties, the dimensions of the tie. So it has 2 ties, it has 2 doors, it has this particular type of glass, all the various attributes, and then things I will need to do will be stated in this particular blueprint. So the blueprint is like a form, right? That, or a questionnaire that you fill with all the things you need, and then you give it to people in the factory, and they will look at it and they will create the object called a car, right? So a class is a blueprint we use to create the object car, right? So behind every object there is a blueprint called a class. So that means that everything in Python is an object, and everything that is an object has a blueprint behind it which we use to create that particular object. So let me explain what I mean. So by the end of this tutorial, we're trying to explore all of these aspects of object-oriented programming. We're going to explore why everything is an object and everything is a type, ways to create your own object, which you have seen that to create an object you need a blueprint, which is called a class. And then we're also going to explore the OOP principles. Most of the time they are 4, but they are actually more than 4. So you have inheritance, encapsulation, polymorphism, abstraction, composition, association, aggregation, right? So we're trying to explore some of them. I'm going to see how to work with ABC, metaclasses, and then solid principles. So let's start with the first one. So everything is an object. So you have understood what we mean by an object. So an object is anything that has state and behavior, right? State is data, behavior is the methods it does, and then it is created using a blueprint called a class, right? Perfect. So that is a big understanding. So let's see. So since everything in Python is an object, right? And an object has a blueprint that we use to create it. That means that if I want to check for the type of that particular object, I can go back and check the blueprint to see it. So let's explain what I mean. So let's say I have some values here. So we have A is 1, B is hello world, C, I have all of these particular variables, right? If I want to check for the type of this particular stuff here, so I want to check for the type of this. So I want to check type of object this particular one is, right? The type of object this values are. We use, how do you do that? So we use the type option, use this particular type. So type is a function as well as a meta class. We will explore it later on. So we explored why this is both a function and a meta class, right? So if I go with let's print this particular type of A, if I check it out, it's telling me that okay, the type of object for this number A, right, is an integer, right? So 1 is an integer. That is why it's telling me that okay, the type of this particular A is an integer. But why is it showing the class here? Because we said every object needs a blueprint to create that particular object. So the class is the blueprint we use to create this particular object. So that explains why we have the class here. So it's telling me that okay, this particular number is an integer, right? It's an object of the type integer. And then how we create it, we use a blueprint, right? That is why it is called class. That is of the type integer. So that particular blueprint, which is a class, is integer, right? So we use the integer blueprint to create 1, right? Basic understanding. If I go back again, I just do, let's say, print. Let's do the other one. So I want to print for, let's say, let's go this one. This is, yeah, type. Let's go with this. Apologies for how it's going to be. Now check it out. The first one, the number it is storing is an integer. The number it's storing is a string. So it's telling me that okay, the type of object for this one, for A, is an integer, for B is a string. So in other words, you can say that this is going to be narrative. You can say that str or int, right, is the class used to create the object called strings, right? Oh, did I say string? Integer. Yeah, that's the big understanding. So this is what it means. So int is the class used to create the object called integer. Again, string str is the class used to create a string object. That's a big understanding, right? That is a big understanding. So in other words, it is the class, or as we already saw, blueprint used to create the object called integer, and then string str, right, is the blueprint used to create string object. That is the basic understanding. So everything in Python, if you want to check for the type of every object in Python, you use the type function, and then that type function is going to tell you, okay, this is the particular blueprint or class we use to create this particular object, and that particular blueprint is the integer or is the type, right? Perfect. So now we have understood that behind every object there is a class, right? So what is also behind the class? What do we use to create this blueprint? We know that to create an object of a car we need a blueprint, but what do we use to create this class, right? What do we use to create this blueprint? We know that blueprint is a paper, so let's check it out. So what is behind, what is used to, let's give the hierarchy. So now we know that there's a hierarchy behind every object. There is, let's go with this. So we use a class to create an object, So what do we use to create, what is used to create a class, right? or that particular blueprint that we have. So what do we use to create that particular class or blueprint? So that is the question we are asking. We know that we use a class to create an object, but what do we use to create a class? That is where the concept of type comes inside. So we use a type. We use type to create a class, right? That is a basic understanding. Or we use Metaclass to create a class, right? That's a big understand. So both of them are the same thing. So we use a type to create a class, and we use a class to create an object, right? So what do I mean by, how do I know that this is what I'm saying is true? So if we take this one here, we saw this one here, right? The type of this give us int and string. So if I go back and I just do the type of this particular int, what is it going to give to us? So let's go with print. It's going to be the type of the class. So I can check the type of the class. If I check it out, type of the class, let's make it this way. So the type of the class integer, right, is type, right? So when we did this, the type of A, we got that, okay, we use the integer blueprints or integer class to create integers. Now, what do we use to create this particular integer blueprint? That is the type. So if I check the type of this, type of int, the answer is that it's a type. So type is, so in other words, type is the class, or is the, is the meta class used to create a class, right? Type is the function used to create a class. So in case you want to create any class, you need a type. So back again, we have an object. In case you want to create an object, we need a blueprint. The blueprint is a class. What do we use to create the object? We use the blueprint. What do we use to create the class? We use the type. Yeah, let's take this one as a type. So that is a basic understanding. That is why if I go with the type of this, or we can also do this one like this. So we can also do this. So the type, so type of the type of A, right? So what you have done so far, yes, here you're getting the same thing. So the type of A is a type. So now the hierarchy now is going to be this option. So now the hierarchy or order is that, I know maybe it's becoming some way, but I hope you understand what I'm saying. The order is that we have this, a class is object, and then we use a meta class right to create the object, right? So a meta class, or let's call it as I say a type, right? So the order is that we use a meta class or a type to create a class, and we use a class to create an object, right? Very nice. That is a basic understanding behind it. So everything in Python is an object, and everything in Python is also a type, because we use a type to create that particular object. Very nice. So we have come to conclude that everything in Python is an object, and everything was created by a class, and every class was created by a type. Now, as you already saw here, we have a number, we have a string, we have a list, we have a boolean. Now if I go back again and I just do the same thing, so print for type of C, print the same, the type of D, right? You know that this one, the first one, and you can see that this was an integer, a string, a list, a boolean, right? Perfect. That is true. Now if I go back again and I do the same thing for the type of all of them as we did here, so let's try it again. Every object, everything So everything in Python is an object and a type, right? So if I go back and I do the same thing here, we have the type of a type, and as we did earlier on, we're going to, let me write it well so that you see it well. If I go back and I check it out, you can see that the type of an integer is a class, right? So all of them, whether it is an integer, whether it's a string, whether it's a list, it's a boolean, if you check for the type of the type, you are getting all of them as what type. So the basic fundamental stuff is a type. Then all of them are created by a class of an object, right? A class of that particular type, and then we have an object. Okay, so let's go back again and recap. So to recap, you have understood that the hierarchy is that there is a type, there's a class, and an object, right? Every object requires a blueprint to create it. That blueprint is called a class, and what is used to create that particular blueprint is called a metaclass or a type, right? So we understand it, we'll go into metaclass later, but you just have to understand it here. So a class is a blueprint or like a cookie cutter for creating an object. So an object is anything that has state, as we saw earlier on, data and behavior, right? So let's go back again and then explore it further. Now before we move on again, there's another way you can also check, right? So all, as I said, we had this A here, right? So this A here, if I go back and I just check for the print, if I print A, which you already know, and then I go back and I just go print the type of this particular A, we saw that it is a class int, right? So every object has been created by a class. So in that case, if it has been created by a class, I can also do this. So A dot underscore underscore class underscore underscore class. If I go with this, it's going to tell me the particular class that was used to create this particular object. You can see that it's telling me that it's what? Int, right? So this thing here is equivalent to doing this. So this, right, is equivalent to doing type of that particular A, right? So this is equivalent to doing this, right? That's a basic understanding, because when you call this particular function type, it's going to go and check for the class that was used to make that particular class, right? That's the basic understanding. It doesn't matter what it is. So in the same way, I can also do this. So it doesn't matter. So the class, the type, the class behind this, the blueprint behind this object is equal to the type, right? Again, I can also do the same thing. So A dot, I want to get the blueprint behind this particular blueprint. I'll just go with this. So this is also equivalent to doing type of the type of A, right? So that's a bit understanding. So let's check it out. If I go with the first one, we saw the first one gave us this type. It's like we got the same type. This is similar to doing this. So let me put it here. So you have print, you have type of A, we have, yeah, if I print it out here, it's giving the same thing. So the class, so this is reading like this: the class behind this particular class is a type, and the same thing as you can see in here. So all of them is true. So this is the same as this, right? As you can see, or you can make it better if you want to be more sure. Yeah, true. So you can see that it is actually true. It's not like that is a result here. So this is another way. So if anytime you call this particular function type here, what it's doing behind the scene is that it's going to go to that particular object that you have created and get the underscore type of it, right? And if you want to know the type of the type that created that particular object, just go with double of it, right? So let's try and see if we can get the type of the type of the type. Let's see. This is just experimental, right? I don't know what is going to happen, but let's check it out. This is level 3, so dot underscore class. It's still a type, right? So the type of a type of type is always a type. So the fundamental level behind every one of them is, so this is the fundamental. So how to get the type of a type, right, which is the same as the fundamental behind every class, right, using, that is a basic understanding, behind every class or object. That is a basic understanding. So the type of a type is, so the first hierarchy, this is going to give us the class. The second hierarchy is going to give us the type, and then from there it is the meta class. It's more abstract stuff. That's the basic understanding behind it, right? So now let's see how to create a class in Python. So we already know that a class is the blueprint used to create an object. So let's see, how do we do that? So how do you create a class in Python? How do you create your own class of a particular type, right? So these ones are immutable. So int is immutable, right? String is immutable, but list is not immutable. So how do you create your own particular class, your own blueprint? So let's see how to do that. So we're going to check the first method. So this is going to be method number one. How to create a class. So this is using the constructor, right? So the constructor in our case is going to be the underscore init underscore this. So this is going to not just create, this is going to create, right, and then initialize. That's why it is called initialize, right? So init. So this init is going to create and initialize, right? To actually create, you just go with the underscore in, which you will explain later. So let's see, it's going to be class. Let's create something very simple. Person. Apologies for my keyboard. So class, and then to create it, just go with def underscore init underscore, then just go with myself. So self is referring to this particular object, and then just give the attribute. As I said, in case you want to create an object, you need a blueprint, a class, and every class has an attribute and a state, right? So that is where we just go with this. So self, I'm going to specify the attribute. So let's go. Every human being has a name. So let's go the first name, and then every human being has a last name. Not every human being, but a person has a last name. Perfect. So this is how to create it. So init, not ini. Perfect. And then you have to, so this is the initialization, and then this is the assignment. So you have to assign it. So self dot first name is equal to the first name here. So this here is an assignment, right? You're assigning it, right? You're assigning this particular one to this one here. So these ones, this here is going to be the attribute, and this is the argument you are receiving, and you're going to assign it to this, right? So here, this is the attribute, but this is the data you are going to attach to this particular, or assign to this particular name. So self dot last name is going to be last underscore name, right? So that is how to create a class, right? So let's check it out. So now I've created a simple class. In case I want to use this particular class, so I can just go with this is usage of the class. So this is creating an object from a class, right? So if you are creating an object from a class, you can see that we are making an instance, right? Also called making an instance. So making an instance of that class, right? That's a bit understanding. So that is creating an object from a class is making an instance from it. So if I go with p is equal to person, I just go with this option here. So person, then I'm just going to pass in my values. I'm going to pass in the first name. So let's give a first name like everybody likes his name, Jesse. Then the last name, JCharis. Yeah. So in this case, if I run this, this is now an instance. This is now an object, right? So it has some attribute, and it has a state, right? If I go back and I just go with p, now you can see that it's giving us main here, right? And then it's giving us the particular type. So the type of this particular object that has been created is a person, right? So that's why we have person here, and it's giving us this particular value here. So what does this value mean? So let's explore it one after the other. So what does this person mean? So this is the type. So if I go with, so if I want to check the type of this, the type of blueprint used to create that object P, right? I'll just go with type. I'll just go with my P. So we have person. So this here is the type of blueprint, into brackets, class, or class used to create that object, right? So that is it. I can also do the same thing as we did above. Yeah, you can also do this. Remember that we could get the type of it by going with this option here. So you can just go with p dot underscore underscore class underscore, and it's given us the same thing, right? So either we use this or use this, right? So as you saw the idea behind it, perfect. But what does this mean? What does this particular mean? So anytime you create an object in Python, it must assign a memory location for that particular object, right? So in case I want to know where this particular object called P of the type or of the class person is, so it's telling me that, okay, I've created an object called P. It belongs to the type person or the blueprint person, and if I want to find it, it is found in this particular garage, right? In this particular place. So this is at this particular place. So how do I know that it's at this place? So in case you want to check, you can just go with this. It's how to check for memory address of an object, right? Just go with E. So because the reason we are going with this, we just go with this particular function, ID. So the ID function is going to tell us the direct identity of memory address. So inside the memory, right, where it has been allocated. So it's going to give, how do I call it? Within the memory, right? Check for the memory address of an object. Or yeah. So we use the ID to identify the particular memory address, right? The identification for that address. So as you know, if you have an address, a PO box of a place, the PO box is used to identify you, especially in Germany. So the PO box is used to identify you, right? It's used to ID you, ID a person, right? So your address is used to ID a person, right? That's a bit understanding. So we can use the ID function to be able to get the particular address, right? So if I go with ID of P, right, check it out. If I go with ID of P, so I just given out this number. So what does this number mean? Right, it looks different from it, but no, it doesn't look different. It's the same. The reason is this particular number here, this number is a hex number, right? So this is hex, right? This is the hex number of it. So this number here is equal to this. So this number, so the narrative is that this number is the hex number for the ID, or let's call this for the ID of the memory address. That's a basic understanding. So if I go back to and I check, let's say hex to decimal converter, if I come back here and I paste in this number here, this particular number that we have, if I copy this and I paste it here, just check it out. Convert. So I've gotten the same number, 14056. It's the same number we got here, right? So I can also do the same thing in Python by going with this option, int, and I'll pass in this particular number here, right? So this is going to how to convert. So I'm converting, let's convert a hex to decimal. We have gotten the same number. So this value here is the ID for it, right? So if I go with ID, it gives us this particular number here, and then this is it. Anytime I create another object, it's going to assign a different ID, except we use singleton pattern, right? That is where singleton pattern comes to play. Right, so the narrative is that anytime we create an object, right, using this particular one, we're giving this particular result. So this is the particular type of blueprint or class used to create this particular object called P, and it is stored at this particular memory address with this particular ID, and this is the hex number. And in case you want to check for the hex number, you just use an online hex to decimal converter, or you can just go with int, right? I go with int, we can get it here, right? Perfect, right? So it's going to convert it from hex to decimal. So now you can see that this number ID is the same as the one here. So that is going to be our simple narrative. Right, perfect. So we have gotten a simple narrative of it, right? Perfect. Okay, so in case you have any question or contribution, you can let me know, right? So we have seen how to create an object in Python. You have seen where that particular object is stored. If I run it again, it's going to give me a different number, right? Because it's going to allocate it to a different place. So if I run it again, right, and I check it out again, the number has changed. You may think it has not changed, but it has changed. Because if I go back and I check it out with the previous one, so this was C is 76B, this is 76B640, this is 76B4C0, right? So it has changed. So every time you run it, it allocates a different one. So in case you wanted to maintain the same place, you use the singleton pattern, right? That is why we use the singleton pattern. So you can also add it to the narrative. So the ID change, so you run it, right? You run it unless you, let's say, use a singleton pattern, right? So that means it's going to be first for that particular one, right? Maybe that is a basic understanding. Or except that is something basic. You go into details into that later on. Okay, so that is a basic understanding. So this is the first one, and let's go with the second one, so that in the future we will know that we run two different results. So this is the new one. So that this is the new, right? Right, perfect. So in that case, if I go back again and I just go with int, this, the future is the first one. First allocation ID, and then this is going to be the second one. Second. Perfect. So that you see that it's different. Okay, now we are done with creating an object. That is the first method. Now let's see the second method. So the second method of creating an object is to use the underscore in it. So let's go to method number 2. So method number 2 of creating an object. Right. So that is the second method. So what is the second method of creating an object? So in order to create an object, the second method, in this case, you are going to use the option of the underscore new, yes, plus underscore init. So this is going to create a new object, and this is going to initialize it. That is a basic understanding. So why the new? So why the new? So the new, so why do we use this particular new? So the new is for creating a new instance, and then the init is used for initializing it, right? So let's start with what I mean. So I'm just going to go with this. So class, same person with this. So class, let's bring it up to, right? And then I'm just going to go the same. So def underscore underscore new underscore underscore CLS. So CLS is the class itself, inheriting from. Then let's print out something so that we know that we're actually creating something. So let's go to so creating an instance. Then after that, I'm just going to go with this one. Anytime you're using this particular method, you have to also initialize it. So init, and this one goes self. Then let's print so init is called, right? Something like that. Now if you have created a simple class using this particular option, but because I have not initialized this with any variables, because I'm not signing anything, if I go back and I just create p2 for the new class, I go with person 2, so you see that only the new was called, right? So creating an instance, only this one was called, the init was not called. So why is it? Because that is why we use init. So the init is not just going to call or create an instance, it's also going to initialize them, right? So this, if you use this one, it's going to create an instance, but it's not going to initialize them, right? That's the basic understanding. So in order to fix this, just have to go with this option here. So again, when you use new, right, this new here, the instance is created but they are not initialized, right? So in order for the instance to be created and initialized, you have to just use the super, right? That's the basic understanding. So in that case, just go with this option. All right, so just created, and then I can just go with return super. I'll pass in the class, so person 2. Then I'll pass in the CLS for the class itself, then underscore new. Then I'll just close with this. So you see that this is more complex, right? It's more complex. So this is, in this case, this option here is going to create an instance, right, and then initialize them, right? Using this one, we use using the super. So if you use this one, that is what it's going to do, right? So run it again, and then I come back again, just check what it's going to do. So let's bring this one here, check it out. So the first one, because we did not use the super, we got to create an instance. But if I go with this option here and I run it, so now init is called. So the super is one of the powerful features of object-oriented programming in Python and in Java. That means that if time you call super, it's going to call the parent class and initialize them, right? And initialize everything from the parent class. So calling super here is going to initialize everything of the parent class with this person, and then it's going to initialize it. That explains why the instance was created and then init was also called, right? So this is another way you can also create an instance. So I'm going to put a lot of information here so that I can use. There's also another third method using the call, but we will not be going there, right? So you have seen two methods of creating an object. The most recommended way, which most people use, is the first one. This is mostly what is going to be used, right? These things, you will not use them most often, except if you want to do some advanced stuff here. Okay, so that is something very big. So I've left some notes around so that you can also check it out, right? Okay, so let's read it. It says that the new is intended mainly to allow subclasses of immutable types, so like integer, strings, or tuple, to customize instance creation. New is a static class method, whilst init is an instance method. So init is an instance method, but the new is a static class method. So we'll explore that later. So new has to create the instance first, so that init can initialize. So that's what we saw here. So as you saw, the new will create it first, then the init is going to initialize it, but it only does that when you call the super, so that it's going to inherit from the parent from here and then call that and initialize the init. Okay, so use init when you need to control initialization, and we use underscore new when you need to control the creation of a new instance. So in case you want to control the creation of an instance, use new and then you modify them as you want. But in case you want to control the initialization of a new instance, you just use the init. So new is the first step of instance creation. The score first and is responsible for returning a new instance. But init doesn't return anything. It's only responsible for initializing the instance after it has been created. Very cool, right? That is the basic understanding behind it. Okay, so you can read more from that. It's available. I took it from Stack Overflow. Yeah, that's one of the best places to learn. Among the best things to learn, right? Okay, now we have seen how to create objects. So the other alternative is method 3. This is method number 3, which is using the underscore call, which we will not discuss. We will do that later, another time, right? Okay, that's the method number 3. Now let's move on from here and let's see what are the components of a class. So to recap, we have seen that every object has two things, state and behavior. And in case you want to create an object, you need a blueprint and the name of the type, the blueprint, right, which is called class. And there are different blueprints. And in case you want to create a blueprint, you need state and behavior, right? You have seen two methods of creating a blueprint, and behind every blueprint is the type, right? Okay, that is the basic understanding. Now let's see the component of a class, right? The component of that particular blueprint. So every class has a state. Every blueprint which is used to create an object has the state and then the attribute. State, attribute, and behavior. So an instance of an object is the state plus the behavior. Then the object or any object has attribute and methods, as you saw here. So let's see how to create or explore more of the component of a class. Now, so we have seen how to create a class and we have seen the component of a class. So if I go back to the class we created, which was this one here, the first one we created, this is what to be using for most of the time. To copy this one here and then going to explore the component of this particular class before we move on, right? So if I go back here, this is what we created, right? So these things are the attributes and these are the attributes, right? It doesn't have any method yet, right? So in case I want to get all the attributes, so how do I get all the attributes of this particular value? So p is equal to person, then we already placed in a name, so everybody likes their name. You can do it this way, right? And then you can also put it like, let's say, yeah, you can do it this way or you can also do it this way. So p2 person, right? And then just put in this a first name, let's give it another name, so Marcus, and then the last name. You know, you have seen that I made a typo somewhere, right? It's going to be Aurelius or so this is how it's supposed to be, right? So either you use this one or any of them. So any of them is going to work, right? That is, if you use these particular values, it's going to work, or you use this, any of them is going to work. So how do you get the attributes of an object? How do you get the component of all a class, right? So to get it, there are several ways you can do that. So the first one is that in case I want to get the attribute, I can just go with this p dot, right? That is dot syntax, and I'll just pass in the particular value there. So we have p, we had first name, so first name. So this is how to get the attributes of an object, right? So dot first name. We don't put here, no, just go with this, right? You can also do the same thing for the last name. So p dot last name, and I get it here, right? So this is how to get the attribute of an object. This is not just going to get the attribute, it's also going to pick the data that is on that particular attribute. As I said, an object has state and behavior, and then it's a blueprint, and on the blueprint we have details, right? So there are values, there are data on that particular detail. In case you want to get that actual data, you call the attribute. So p dot first name or that particular attribute, and you get that particular name here, right? Very nice. Now, how do you get all the attributes? So in case I want to get to how to get all the attributes of an object, right? How to get all the attributes of an object or of a class. How do I do that? So there are two ways. The first method is going to be method number 1. So how do I get all of them? The first one is just go with this option. Yeah, let's put it here. This method number 1. Method 1 is using the var. Right, if I go with vars, it give me all the variables, right, for that particular attribute. This is one of the methods. There are several methods, but this is one of them. So let's try it out. If I go with vars of p, that is going to tell me that, okay, all the attributes of that particular class, right, of that particular object is this. So we have the first name, which is an attribute, and this is the data that's being stored there, the last name, and this is the data that's being stored there. This is like a dictionary, right? So dictionaries are very powerful because it is very useful to store data because of how it works behind the scene, which we will explore later on, right? You can also use another method, right, which is the third method. So this is number 1, number 2. You can also use method number 2. You can also use this option, DRR. So if you have been watching my tutorials, most of the time I use DRR because DRR is very powerful. So DRR can also be used to get them, right? But the difference is that this is going to return, this will return the attributes and then the variables or data stored in the attributes. Right, that is the basic understanding, right? So you can see that it gave me the attributes, it gave me the data stored there, but this is not going to give you that. This is going to give you all the attributes, right, without the data, right, and more. This returns the attributes, right, as well as, so this retains the attributes, right, the instance attributes and the variable or data stored on them, but this one retains the instance attribute, so instance attribute, right, and the class attributes too, and all the ancestors. Yeah, everybody above it, right, without and this one doesn't include the actual data stored on it. If I go with this, it's going to be a lot. It's going to give me the class, right? So that explains why we can do this option, class, dict, DRL, docs, E, all of these things are everything that it belongs to. So it retains the instance attributes as you saw earlier on, which is the last one. These are the instance. There's going to return all the ancestor or the class attribute. So these are the things which is very powerful, right? So the reason we could do this, if you remember, we could do p dot, right, is because see that is what is here. So the DRL is very powerful because it retains the instance attribute as well as the class attributes and all the ancestor attributes. Right, very, very powerful, but not the actual data stored on it. That explains why we could do this. You could also do this to also get the values stored on them, right? So this here, we could also do this again. So p dot underscore date underscore this is going to return the same thing here. So this is equal to type, this is equal to var, right? As you can see here. You can also do the same thing. Remember, there's also a call here. So this thing here can also be done this way. So let me come back here. So this, remember this one, we already saw this one. You can also do p dot underscore underscore drl underscore underscore, right? It's a function call, right? That is why we're able to apply that particular function call, right? Okay, that is a basic understanding behind it. So in case you want to get all the variables, you can just use this method, or you can just use underscore underscore object to get all the attributes as well as the variables stored on them. In case you want to get all the attributes of an object and the class together with the ancestor attributes, the class attributes, you just go with DRL, right? That is how to get attributes of it. Perfect. So that is so what is the difference between the vars and then the so as you see, the difference is that the vars, as we saw, this displays the attribute of an instance in the form of a dictionary and only works for objects that implement dict function, right? This particular dict function. It explains why we could do this to get it, right, as you saw earlier on. And then the DRL, it displays the instance of attributes and the class attribute as well. It's not limited to that instance only, right? Very nice. Okay, now let's move on to one more thing before we move from the objects. We are going to go with the user experience, right? So as we have been seeing, when we created our classes above, when we created this particular class here, this particular class that we created, let's go back again. If I go with this option here, this is what we created, and when I created this PE is equal to, let's copy it and paste to save us time. So when I created this, so let's go back again. When I do this option here, right, and I go with P, so it's not nice. Even if I do print P, it's not nice, right? It's not friendly. It's not user friendly, right? I know I place JC and JCharisTech, right? But if I call P, it's giving me this particular value, and if I print it, it's still giving me the type of object, right, which is a person object with a person blueprint or person class at this particular memory location. But then this is not friendly. So how do you make it user friendly? That is where we go with the underscore underscore rep and underscore underscore string. So this one here is for the developer, right, for programmers, and this is for regular user, right? That is the basic understanding, just something to help you understand. So let's see how to implement it here. So to implement it, just going to go with this. So def underscore underscore representation, and then from there I'm just going to inherit self, right? So self here, this self here, this self here, I can also call it like me, and it's still going to work, right? I can call it me. Let me show you that I can also call it me, and if I run it, it's still going to work. Yeah, if I call it me and I have to change this one to me, so this can be changed to be anything. Doesn't mean that it must be called self, but by convention we prefer to use self, right? So let me keep this one here. So the self can also be me, so that must be the first thing. So self can be called anything, right? But it must be the first argument. That's a bit to understand. That is the rule, right? So you can call it me and it's still going to work, right? But the recommended way is not to call it me, but to call it self, right? Self. Okay, so let's make it more user friendly. So to make it user friendly, just go with the first one. So this is for the developer. So self, and then how do I make it? So this one is mostly for developers to know how to call this or how to create this object, to create objects with this class, right? So how do you create object with this class? That is the basic understanding behind this. So in any ways, as you could see from our example before, we call the class like this. So person this way, right? That is how we create an object with this class. So that is the same way you put it here, right? So you're just going to go with return, then you can just go with string if you want, then just put in the same thing there. So person, then yeah, right. So this is how we did it. So we go with, since we are using string, it's going to go with my, yeah, then just go with self dot self is referring to itself, then you can just call the attribute here. So first name, right? Perfect. But you could see that we put in quotations here, right? Quotation marks here. So in order for you to represent these quotation marks, you just go with the asterisk r. So asterisk r means that, okay, get the literal string quotation, put it in quotes, right? So asterisk r means put in quotes. Then I'll just do the other one. So let's copy this one here, and I'm going to omit it to show you what I mean, right? So last, so the asterisk, so the asterisk r is to put it in quotation, in quotes, right? That's a big understanding. Then let's do the one for the regular user. So that's the string. So this is going to be for regular user. Right? Just as a regular user. And the purpose is that it's just to show them how they can also call it or create an object, but mostly just to see how beautiful it is for UI. So going to be return, then we can just go with F, the same thing we did above, but this time we can just go with person. Remember that this is how it's supposed to be. You can call that person, right? And then you can make it like, let's say, first name, and let's go. It depends upon you, right? You design it as you wish. So as I said, this is for regular users, so it's supposed to be more informative, right? This is for developers, so in this case I'm just going to go with this option. I'm going to specify, okay, for the regular user I'm just going to put in here. So let's put it this way. Let me copy this one, I'll modify it. Yeah, I'm not going to put quotations, and do the same thing for the last name. Now I'll close it, right? And then I'll close this one. Perfect, right? So that is something very basic, right? So this is how the regular user is going to call it. So run it on. Now this is going to be more user friendly. So this is adding UI, not UI, UX. I call it UI, UX here. Rep, and then yeah. So if I run it now this is going to be better. So if I run this one again and I go back here, it's no more going to give me this. This is the initial one. It's going to give me a better one, right? If I go back with this, now it's that this is better, right? So this is, if I go with this option here, this option here, if I go with this straight away, this is coming from the underscore RPR, right? This is coming from here, right? This is, which is, I said, is for the developer, right? If I call this is coming from the underscore RP, and you can see that, as I said, if you put a quotation, if you put the exclamation and R, is going to put quote it in quote, and you can tell this one is in quote, but this was not in quote. Let's run it again. If I go back again, I run it, so this is in quote, but this is not in quote because I put this exclamation there. But that is not how we created it, right? So the idea behind this one is to allow it to have quotes around it. That's the basic understanding behind the banking. Okay, so if I go with P, is coming from here, so I can also do the same thing here. RPR, then I'll pass in my P. It's also going to give me the same result, right? Perfect. Okay, now let's see the other one. So if I call print is a very powerful function that is going to go back and not look at the representation, but look at the string, right? So in that case, this is coming from the underscore string, right, which is for regular user. So if I go with print P, is that now, so first name, last name, right? So this is coming from the string representation. I can also do this. STR, and it's going to give us the one that is coming from this, right? That is a basic understanding. So this is something for the user design, right? The UI, UX, to make it easier. We use the representation mostly for the developer, right? To show you how it is done. We put the exclamation, R and exclamation behind it to put it in quotes. And then for the STR, this is for the regular user, right? Very nice. That is something very basic about it. And since it's like this, you can actually add more features to it. But that is something for today. Perfect. So that is one, right? Sometimes in the near future, we're talking about inheritance. So sometimes this is okay, but there's also another better method of doing this, so that you don't need to be typing this over and over again. So that in case you are doing inheritance and stuff, you don't need to do that. So this option can also be made better by using this particular option, right? Instead of going with this, right? This is good, perfect, but I can also go with this option here. So let me show you. I can just come back here and just go with self dot underscore class underscore dot underscore name dot. Why are we doing this? It was, remember that, as I said, if I do this, right, and I just do this, we are giving the particular type. I can also do this again, and notice it's going to bring only this person here. Perfect, right? So this thing that we have done, this one, as you saw earlier on, give us a type. Perfect. And in case you want to get only this one, to get the name of the class blueprint, okay, where I call class blueprint, just go with this option, dot underscore name. So we use this particular option, dot underscore name, to get the actual name, right? So this is going to give us the name. So in the same way, we can also apply that same thing here. So let's put it inside a curly bracket, and now if I do that, oh boy, where is it? If I do this, right, it is automatically going to pick from there. So let's copy this one and then replace it with this one, right? Perfect. So run it, and I come back again to what we did earlier on. So let's go back and pick these ones. It's automatically going to make it more beautiful, right? So you have understood why we use that option here, right? So if I run it and I go with P, perfect, right? So this is very useful, irrespective of whatever I'm going to do in the future. It is always going to pick from that, so that I can actually inherit it, right? So thank you for watching this site tutorial on classes. We have explored a lot. We have learned about objects. We have done so much things. So in the next session, we're trying to explore the other aspect of object-oriented programming, which is the behavior. So we have learned about the state. Now let's work on the behavior, right? The behavior represents the methods. Perfect, right? So let's move on to the next aspect. Okay, so this time we're trying to check on methods, creating methods for a class. So there are 3 or 4 different types of methods for every class, right? As we saw earlier on. An object has states, which you have explored the attributes. It has a behavior, right, which is the methods, right, that it does. Okay, so in that case, how do we do that? So there are 4 different methods. So the first one is an instance method, right? The next one is a class method, static method, and there is also another one for which is going to be abstract method, right, which we will not talk about now. We will not talk about that now, right? So an instance method, or simply put, a method is a function for a class that controls the behavior of the object, as we saw here, right? It controls the behavior of that particular object. So that is a method, right? So the first one was an instance method, which is a function. So in OOP, functions are also called methods, right? Yeah. So a method is a function for a class that controls the behavior of the object. So an instance method is a function that takes self as the first parameter and controls the behavior of the object instance, right? So hence it can have access to the instance attribute. A class method, on the other hand, is a function that takes CLS, right? So instance method takes self, class method takes CLS as the first param, and have access to the class itself. And then by convention we use from, right? It's underscore from, and it uses the at, that is the creator, class method the creator. A static method is a function that doesn't take either self or class. So we have one that takes from the self, one that takes from the class, and the other one that doesn't take from any of them. That is the static method, right? And it's actually live outside the class, but we use them because they are utility functions. Let's see how to implement these things. So I'll go back again to our initial one here. We have this particular one, this is what we have been using. So I'll go back again, and this is going to be my class, right? So we'll be creating our first object. So this is our methods. So let's call that our first instance method, right? How do you create instance method? That controls, that governs and controls behavior, right? So that is a basic understanding. So it must first take an, so let's create one. So I'm going to create a simple one. So this is going to be something very simple we're going to create. So let's call it as def. We want to create an email from the person's name. So it takes in self, that's the rule, number 1. And then it's going to return the email. So let's return the email of the person. So let's go with this option here. So I'm just going to use something like this. You can use a string if you want, but let's try a different option. Then I'm going to go with my at gmail.com, right? You're going to create for Gmail. Then let's go with dot format self dot the first name. We're using the first name to create the email. First name. Right. So this self first name is referring to this first name here, right? So I'm going to create an instance method. So this is a simple instance method you have created, right? So this is an instance method. You can also create another one for a password if you want, right? So this one doesn't take in any arguments, but you can also create another one. So this is going to be another instance method that takes arguments, right? Add arguments. So def, let's create a password from the name. It's going to take in the self. It must remember that an instance method always takes self. Then it's going to use it to modify or govern the behavior. Then it's going to take in a value, right? A secret number. So now we're going to return a password. So we can just do the same thing we did with a string. Let's use a string, which is going to be this option. So we are going to pick the last name of that particular person, right? And then you're going to take, let's say, the value you have added. So we are going to pick that particular value. So in that case, this is going to be this option. We're taking the value. Yeah, my mouse is behaving, that's why. So that is all, right? So you have taken the person's name and the value to create the password, right? So let's also add another one. I'm going to add another one. So let's add another age to it. So age, you're going to add another variable here. Yeah, right. And you can also add that one here in case you want. So just to make it look interesting. Remember the point of this. This is going to be for the age. Yeah, and now we can repeat it for the other one. Yeah, right, so that everything is working as expected. So what we want to do is that we are creating, you have two instance methods, one that doesn't take any argument and the other one that take another argument, and you're going to add the person's name, the value, and then the age. Let's add the age first. So let's go with the age, self.age. Right, perfect. So this is going to return that particular value. So this is how to create an instance method. So let's see how to use those methods. So to use a method is very simple. Now let's start with this. So this is calling the method, right? So it's going to be this option. So I'm going to create a class. Let's pass in some value. So let's add the age here. Yeah, and then we just go with p, right? Then to get the method, just go with dot, say create email. This is going to create the email from the distance, and you can say like I just created the email here, right? jesse@gmail.com, right? Perfect. In case I also want to create a password, so p.create password, then this one takes the other value here, so I can just pass in another value, and now it's going to create my password, right? JCharisTech2777, right? Very nice. So that is how to use instance method. The first one doesn't take any argument, this one takes an argument, so you can just pass in as many arguments with it, and it has access to the value or the data stored there. Perfect. Now let's move on from here, and then let's go on to another one. So these particular ones, the create password, create email, they are bound to that particular cell. So if I go back and I do the same thing, I just go with create password, right, without the comma. So this is a bound method, so it is bound to this person, right? So this is a bound method, right? Now it is bound. As you know, method is also a function, so it's a bound method to the instance of that object, right, or class created. I hope you understand, right? So it is bound to it. Perfect. Now let's move on and then work on the next type of function, which is the static method. But before we move to the static method, let's move on to the class method. So this is going to be class method example. So class method, they take in the class as the first one, and they have access to the class itself, right? So that is the basic understanding, and as you saw, by convention it goes with from or to, right? You can just use from or to. So let's see an example. So I'm just going to go back again and then copy the same thing that we have created, then you'll be adding that one to it. Yep, the same thing we have. This is no more the instance method, this is the class method. So how do I do that? Right, so we want to add a class method. So we want to be able to, when the person gives the age, we want to automatically get the date of birth, right, the year that the person was born, right? So that is a function we are creating. This function is going to get, this is going to be a class method, right? And what it's going to do, I want to get to create a function. So this is going to be a function that's going to get the date that the person was born. So from birth year, I want to get it. So the option is just go with CLS, that's the first rule, right? And then I can now pass in the other argument. So first name, last name, right? And then I also want to get the year, right? So the class is mostly used for reference to the class itself, right? So that's the basic understanding. That is why I'm passing in these particular ones. So it's going to take the first name, last name, and then the year. Then I want to use date time, so I'm going to go with, so from date time import date. This is from Python. Then I'm going to return CLS for the class itself, which is CLS is by convention referring us to the class. So CLS, I'm going to pass in my values, so first name, last name, same thing that I'm receiving. Then I'm going to do my modification, right? So date dot today. Then I'm going to subtract that one from the current year, right? So what I'm going to do is that if the person supplies the year, right, we are going to pick from the first name, last name, and then we are going to subtract it and return the value, right? So that's the bit understand. So this function is a very simple function. What does the function do? The function is going to function that returns the year the person was born, right? That's the basic understanding, right? From birth year. That's something simple we are creating. It's going to take from which birth year the person was created. That is the class method. If I run it, I can also create another one. So for this to work, right, we have to call the add. We have to specify that, okay, this is a class method. So class method. That is all. I can also do another one. Let's add another one to it, which is not going to be from but to, right? So it's going to be to the birth year. So it's going to take in the age of the person, not the year but the age. Then I'm going to subtract the age from it. So this is going to return the year was born given the age, right? So the person supplied the age is going to return the year the person was born, right? And this is going to return the particular person's year. So returns the age. This one returns the age, and this one returns the age the person was born given the year. So this one is going to return the age the person was born given the year. It's going to return the year the person was born given the age, right? So from birth year, right? So give the person's birth year, give me the date. To birth year or birth age, you can just call it as birth year, anyhow it is. Yeah, something like that, right? So from birth year and then to age. So let's run it again. I'll go back again and now just create my function. So how do we use it? How to use class methods. So as we said, it always go with the convention. So I go with person dot from, right, then birth year, right, and I'm not going to put in my value. So I'm going to put in my first value, which is going to be the person's name, So Jesse, and then Jones, changing the name. Then I can just give the year. So let's give the year that the person was born. Yeah, something like this. So I'm giving the year and I want to get the age. So from the birth year I want to get the age, right? So now we have gotten 27, right? Very cool. Once I pass in the year, it automatically give me the age. So now I can use this one to create my class, right? So I can use this to create my object. To create a new object from that class, right? So now I can just do this and I can get my P4, P3. Perfect, right? And I've gotten my result. You get the point. So the idea behind the class method is that it inherits the class as the first param, and it's going to do something, right? That's going to affect the class. So now we are using it to return a blueprint that we can use to create an object, right? So we use the result to create a new object from the result. So we use the result, right? Or which is in this case blueprint, or a class, to create a new object from that result, right? That is what we did here. So let's try the same one with the to age. So how to use it again? This is to age. Right now, if I pass in the age there, so let's pass in 27, it's going to return 1995, right? So this is another way you can also use it. So that is one of the usefulness of class method. So the idea behind creating class method is you just have to put the class method on top of it, and the convention is from, and it takes in the CLS as the first and returns the CLS, right? Perfect. Now let's move on from here and work on the static method. So let's go to the last one, and then we will end with, we'll wait there and then move on to the OOP principles in the next session. So this is going to be for static methods. So static methods are utility functions. They don't take, so neither self nor CLS, right? So they are not self or CLS, so they are totally outside, so they can be used outside. So they can be used outside the class, right? So let's see an example. So in our case, it's going to be this option. So it's going to be my static method. So we want to be able to get if the person specify the age. We want to know if the person is an adult, a child, or a teenager. So how do we do that? We can actually create a simple function. So it's going to be def, then let's say get age group. So this one doesn't take anything, right? It's going to take a value, right? And then it's not inheriting CLS or self, it's just working on itself. So age, let's specify that the age is going to be equal to value. This is not the best way of doing it, but let's make it like that, right? Or let's go with this age here, right? And I'm going to pass in, so if age, let's make it simple, is equal to 12, is less or equal to 12, they're going to return that this person is a child, right? Else, if the age is greater or equal to 13, and then the age is less or equal to, which age is this then? Yeah, 19. Less or equal to 19. Yeah, we are still, let's return a teenager. 19 is not a teenager anyway, but it's still under 10. Else, if age is greater than greater than or equal to 20, or it's greater than 20, or yeah, greater than or equal to 20, that person is an adult. Return an adult. So adult, and this is going to be a teenager, right? Else the final one, we tell the person, okay, return none, i.e. the person is none of these. Okay, so this is a utility function. I can copy this function and use it outside, and it's still going to work. So any function that you can copy out of a class that's no relations, no access, no connection to the class, and you can use outside, that is where we use static method, right? So to make it like that, I just go with my, so it's a utility function. It doesn't take anything from the class. I can use it outside. So we just go with static, but it's better if I include it, right? So if I go with this option here, as I said, I can actually use it outside. So I can use a function outside. Outside the class, right? And it's still going to work, and it's fine, right? As a utility function. So in this case, if I want to run this, I can just go back with this. So person dot say get is the usage of it. So let's go with the usage. Right, I can just go with person dot get age group. So get age group, and I just put in, let's put an age group there. If I put this there, it's an adult, right? So this can be used outside. I can actually cut this one out, as you are seeing, and it's still going to work, right? I can cut it out, because if I cut it out, I can also do the same thing. Get age group, I put in, still work, right? So this, anytime you have a function or a method within a class that doesn't inherit anything, it's not inheriting self, it's not having any access to the attributes there, or to the class attribute, or to the instance attribute, it is a static method, but it's used as a utility function, right? So in that case, I can actually use it here. So that is the basic understanding. So you have understood the 3 types of methods in OOP, right, that controls behavior. You have seen static method, class method, and then instance method. And as you have seen, that is a big understanding. So this is a classical example of it, right? So a class method, an instance method takes self, has access to it, and modifies some stuff. A class method takes CLS as a first argument. This one can also be written as self, name, self, blah blah blah, and still going to work, right? And then we have something like this, right? So this, and we also have a static method, right? Very cool. So thank you for watching this tutorial. See you in the next session. In the next session, we'll be trying to explore some of the OOP principles, right? That's what we'll be trying to do in the next session. So see you another time. Stay blessed. Bye.